Okay, folks, on to the next question, which is very, very financy, the core of the finance valuations, if you want. This has to do with valuing cash flows from a risky project over the span of years. Okay, so in finance, when I start teaching at the beginning of the semester, I always remind all of my students about two most important valuation formulas, which is perpetuity and annuity. All the other formulas, no matter how complex they are, like DCF, valuing companies, they're all essentially extensions of those two fundamental formulas. And moreover, the annuity formula is actually an extension of the perpetuity formula. So let me demonstrate to you what I mean. Okay, so this question has to deals with the annuity for that lasts 10 years. So I gave you an annuity formula. So this is present value of annuity here. So what we're going to do now, what I'm going to do now is I'm going to illustrate to you how do you get this formula from just the core formula of perpetuity. Okay. So what's a perpetuity? Perpetuity is a stream of cash flows that starts at date 1. Okay. And if we are dealing with non-growing perpetuity, that stream of cash flows grows, if the cash flows are not growing, so that that level of cash flow is the same each year until infinity. Okay. So in period 1, we have a cash flow C. In period 2, we have a cash flow C. In period 3, we have a cash flow C, and so on and so forth until some period n-1, then in period n, then in period n+1. Okay, so we have a C until infinity. Okay, so in practical terms, you can think about this as long as you can forecast or reasonably foresee, you expect to get C. I mean, obviously, nobody really knows what's going to happen 2 million years down the road, but the reasonable intuition behind this assumption of perpetuity or infinite stream of cash flows is that as long as you're forecasting horizon, as long as you can see, you foresee a payment of C or cash flow C. Okay. So at the same time as we have this annuity, perpetuity, what I want to illustrate to you is another perpetuity that starts in period n+1. Okay, so instead of starting in period 1, this second perpetuity is going to start with the cash flows in period n+1, and then again continue until infinity. Okay? So the perpetuity formula is the simplest to remember. It's the cash flow over the discount rate. Okay, so we're going to denote discount rate R, and we're going to say that the present value of this whole perpetuity, all of the stream, all of the cash flows in present value terms is going to be just the cash flow over R. Very elegant formula. Okay. Now, for this second perpetuity, we have to be careful with the timing. Okay, so let's see how this formula, the perpetuity formula, is treating timing. The first cash flow appears in period 1, and the formula for the present value takes it inside this formula 1 year back. Okay, so the present value when we apply perpetuity formula is going to be as of year 0. Okay, so all of these cash flows, present value as of year 0 is C over R. Okay. Now, if I apply the same formula C over R to my cash flows that start in period n+1, what I will get is a present value as of 1 year back. So I'm offsetting it 1 year. So that's going to be year n. And my formula is going to be the same, C over R. Okay. And now with again, we just find in present value of that payment. So I need to take it back another n years. And so what I'm going to do to that payment is I'm going to take C over R, and then I'm going to discount it with discount rate 1 plus R for another n years. Okay. Now, what you will see is that, I hope you notice already, if I look at this formula versus this formula, I realize that the difference between them is exactly the present value of the cash flows for the first n years, which is your annuity formula. Okay. So annuity formula written over here is exactly the present value of this first perpetuity minus the present value of the second perpetuity, which is C times 1 over r minus 1 over r. And then again, this perpetuity needs to be taken back 1 over 1 plus r to the power n. So it needs to be taken back n here. So difference between two perpetuities. Now, this part over here is called annuity factor. And for the ease of calculation, sometimes there would be tables with annuity factors. That was mostly helpful before the calculators became available on our wrists and in our smartphones, and especially during that time, like there were like tables of annuity factors. We don't need that right now, okay? So most of the times you just type, if you have access to a computer, you will just type it in Excel and calculate it like that. And if you have a regular calculator, you should be able to calculate it. So my advice to you is to remember the perpetuity and annuity formulas. These are really the cornerstones of all the valuation questions in finance, okay? Now let's jump to back to the question at hand and see what the question is asking us. Exactly, okay? So our investment is 21,000. Our investment horizon is 10 years. And our annuity factor is with the discount rate of 12%, which captures time value of money and the risk of those projects, is going to be 12%. So with this annuity factor is 565. So to calculate the NPV of this project, what I'm going to do is I'm going to subtract the investment, 21,000, and I'm going to add the present value, which accounts for time value of money of those cash flows and risk of those. So you never know what the electricity prices will be. And what if those panels break? What if there is service requests or something like that? All of that is backed into that discount rate of 12%, okay? So in taking that into account, what I'm going to find is that this $4,000 savings in present per year for 10 years in present value of terms boils down to a annuity factor of 565. So if there was no discounting, right, that factor would be 10. Okay, so for 10 years I save 4,000. My savings should be 40,000. Because there is time space between those payments, and because those payments are not guaranteed at all, we discount them with the discount rate of 12%. And that kind of brings the present value of those payments way down. So we are more conservative. We take into account the risk embedded in these projects, and we end up with a present value of only actually 1,600. Okay, 1,000. So this is positive, and this is exactly the answer B. Okay, so matches up with the answer that is posted. Just for me, a little bit more explanation of where that formula is coming from, and it's how it's used in finance. Again, all the valuation questions are essentially boiling down perpetuity and annuity, maybe growing annuity, growing perpetuity, if you want to account for growth and inflation. But that's really it. So I hope you take it as a motivation to master those formulas before you enter into the challenge and actually start your adult life and tackle real finance problems in your personal life.